Okay, so today we are going to look at classifying polynomials. There are a couple vocab words and terms that we have to go over before we look at how we classify these. These are things that we're going to use throughout the unit and in different lessons in this unit. To start, we have something called a monomial. So a monomial is a if I do that, one-term expression. You might also hear people say single term, so I'll throw that in there as well. A one-term expression that is a number variable or the product of a number and variables. So it could look a couple different ways. So examples of this are, so we have example of a number. So we got 3. You could also have just a variable. Let's go with just x, classic. Or the product of number of variables. Remember, product means multiplication, okay? So you got your times or your dot, all right? So that could look like something like 9xy. Remember, when I write 9xy, that's 9 times x times y. It's all multiplication. That would still be a monomial. So, like, I could even have something that's kind of crazy, like 100 x, y, z, a, b, c, h, j, k, whatever. All right. If that's all multiplication, that is still just a one-term monomial. Okay. Now that one's obviously a little crazy. You won't really see anything like that. So let's get rid of that. Okay. You'll mostly see stuff like these examples. Okay. So monomial 1. So that leads us into a polynomial, which is kind of what this entire unit's about. And a polynomial, first thing, can be a monomial. So a monomial is a type of polynomial. Or a polynomial can be a little bit bigger and be the sum of many monomials. So both these blanks are monomial. Okay. Now, real quick, review the word sum. Sum, remember, means we are adding. Now, real quick, when you subtract, reminder, subtracting is adding a negative. So this also is going to include subtraction. But if I'm adding or subtracting my monomials, then that creates a polynomial. All right? So the stems of the word polynomial break down to mean many terms. Terms is a word that we've used a couple times before. Obviously, you remember combining like terms from Algebra 1. We talked about terms when it came to factoring, okay? So the terms are the different monomials separated by your plus and minus. So for example, and this will be just pretty random, but if I have negative 4x squared, let's go plus 9x minus 3, I don't know, like I said, pretty random, this would be considered a polynomial. Look, I have 1, 2, 3 monomials, which I'm going to call terms, that are separated by plus and minus. Now notice how I didn't really circle this one right here because that's just a negative attached to the 4x squared. Like that all by itself is a monomial. Okay, I'd obviously have to have something in front here if I wanted to kind of treat that as a subtraction sign, a minus sign, So this would have 3 terms, 3 monomials, all right, separated by plus and minus signs. That whole thing's called a polynomial. So polynomial is kind of a big umbrella term. And then we'll have different words and ways that we can classify our polynomials below. Okay, so to finish up some of these vocab things, here's another thing that we have looked at before. It is standard form. Standard form. So the standard form of a polynomial function arranges the terms in decreasing, you can also say descending, numerical order based on the powers. And that's the key word right here, powers, not the coefficients. So you're looking at exponents when you're putting polynomials in standard form. You want the highest, lowest exponent. So that example I just made of a polynomial, that is in standard form because look, on the furthest left, my highest exponent is 2. And then look, 9x. What exponent is with this x right here that we don't have to write? That would be a 1. And then you have this minus 3 on the end here, okay? 3, there technically could be an x with that. It just would have an exponent of 0. But we never write that because x to the 0 power is 1, not 0, be careful. And negative 3 times 1 is just negative 3. So, like putting x to the 0 doesn't really affect much here. It just becomes 1. Okay, but look, this is why it's in standard form, because you go from 2 to 1 to none. Okay, so your exponents, your powers, are in decreasing numerical order when you are in standard form. So the last vocab word that we gotta look at here is called degree. So the degree of the polynomial is the highest exponent that any of the monomial terms have. Okay, so same thing. If I look at my example of my polynomial up here, the highest exponent I have is 2. I know I've drawn all over this polynomial now, okay? But my highest exponent is 2, so that degree is 2. Okay, so your degree is your highest exponent. And usually, if you're putting it in standard form, that means it's going to kind of be your first one right there. So that's why those two are kind of nice to match up. Okay, so there was a couple vocab terms, stuff that we're going to use throughout this unit, but we're going to use down here below to classify some of these things. So for this classifying polynomial section, we are looking at the same examples in the middle here. And we kind of have two different parts. On the left side over here, we're going to classify by degree. And on the right side over here, we're going to classify by number of terms. So we are going to kind of think about this separately, but using the same examples that are right here in the middle. So let's start off with degree. So if I'm going to classify this by degree, we just reviewed what a degree was. It is the highest exponent in your polynomial. So this first one's kind of weird. A degree of 0 is going to look like this, just a number. Now, why? Where does it come from? Because if I have 5x to the 0, then remember, that is really 5 times 1, because anything to the 0 power is 1. And then 5 times 1 is just 5. Okay, now, once again, do you need all that? No. Like, I could get rid of all this, and it's just 5, right? Okay? But really, that's why it has a degree of 0, because that'd technically be with that x there. It kind of gets rid of it, turning it into 1. So then that's what we call a, constant. That's what we call a constant. So it's pretty much just a number. No x, because the x would have a degree of 0 and turn it into 1. Now, our next one, all right, one you've probably worked a lot with, a degree of 1, okay, it's just going to be a single x by itself. Because look, remember, can I put an exponent of 1 there? Yeah, but x to the 1 is just x, right? So you have that x plus 4. That is a linear function, something you worked with a lot in Algebra 1. All right, think about all the stuff you did in Algebra 1. Slope-intercept form, y equals mx plus b, okay? All those equations, those linear functions that you worked with in Algebra 1, the highest exponent was just 1, x, just x. All right, the next one is ones that we've done a lot in Algebra 2 this year. These would be a quadratic function. Quadratic functions have a degree of 2, meaning your highest exponent is 2. Now, my example over here just has a single 4x squared. Obviously, can I have other stuff with that? 4x squared plus 3x plus 1? Sure. But if your highest exponent is 2, that is a quadratic. We looked at solving quadratics earlier this year. All those equations, the highest exponent was 2. So the last three might be ones that are a little bit more new. Maybe you haven't worked with as much. The highest exponent of 3 would be a cubic. Okay, so degree of 3. Degree of 4, kind of a weird word. We're going to say quartic. And then degree of 5, another Q word, quintic. So there's going to be names. I'm sure some people have come up with names for degrees of 6, 7, 8, 9, whatever. Okay, but in our class, we're mostly just going to stick to kind of these. We're not really going to go probably too much higher than 5. We might see something, but you don't really have to classify it there. So we'll just stick with these ones for right now. But this is classifying by degree, your highest exponent in your polynomial. All right, so if we go to the other side here, same thing. I'm going to use these same examples. So maybe I'll clean this up a little bit. Let's clean it up. Okay, so number of terms. So guys, this is talking about number of terms. This is how many monomials do you have separated by plus or minus signs. So here to start, this first one right here is just a 5. Well, there's no plus or minus sign, so that's just one single term. And we already looked at what that is called. It was our first vocab word, a monomial. Okay, great. Now, when you go to the second example, look, you have a plus sign in between. So when you look at x and you look at 4, you have 2 terms going on right here. That would be your binomial. That's a word we kind of looked at with factoring a little bit. Binomial times a binomial. When we factored, a lot of our answers were a binomial times a binomial. That's going to be a 2-term. Okay, now this third one here, you have the 4 and you have the x squared, but here's the thing. They are not separated by plus or minus. So guess what? This whole thing is just one term. So this is another example of a monomial. All right, and then getting to this third one here. Look, you have a minus sign, a plus sign, which means that we separated 1, 2, 3 monomials here. So this has 3 terms, and this name's going to be a trinomial. So guys, if you look at these 3 different words, monomial, binomial, trinomial, the prefix is kind of telling you what they are. All right, prefix mono kind of stands for 1. All right, prefix bi, 2, prefix for tri, 3. So a monomial, 1 term, binomial, 2 terms, trinomial, 3 terms. Okay, and those are the 3 main ones that we're going to kind of look at. You look at this next example, you have a plus sign here, 1, 2. So look, this goes back to being a binomial. And then the last thing that we're going to talk about with number of terms is, in this last example here, look, you have a plus sign, a minus, and a plus sign. Now remember, this sign out here, there's nothing in front of it, so I don't really want to treat that as a minus sign. It's more like a negative. Negative x to the 5th is just 1 term. So you have 1, 2, 3, 4 terms here. And so here's what we're going to do. Once again, I'm sure there's a name for 4 terms, 5 terms, 6 terms, whatever, okay? But we're only going to focus on these 3 words up here. So if you have a polynomial with 4 or more terms in our class, we are just going to call it a polynomial, where's the I? With 4 terms. And so we'll do the same thing. If we come across a polynomial with 5 terms, 6 terms, okay, you just call it a polynomial with 5 terms, polynomial with 6 terms. We're just going to do that for our class. We're mainly going to focus on monomials, binomials, trinomials, because those are going to be the ones that we probably see the most. So that is classifying polynomials. So guys, you can kind of pick one from each column here. Like they are kind of separated, all right? So like you can see, we had like multiple monomials, multiple binomials. Like let's look at the binomials, like here and here, okay? Like one was a linear binomial, one was a quartic binomial. Guys, you could really much do this for any. You could have a cubic binomial, quadratic binomial, okay? You can kind of mix and match a little bit here. So to finish up this lesson, we're going to look at these last 4 examples. And here's what we're going to do for these examples. We are going to first put it in standard form that we talked about earlier. Then we're going to classify it by degree, which was also up top in our vocab. And then we'll classify it. Now, if you look at our directions, we are only going to classify these polynomials by degree. Could we do by number of terms? Yeah, maybe we'll briefly talk about it. But for the classification that we're going to write as our answer, we're going to classify by degree. Which ones were the degree? That was over here. So we're looking at these words right here. All right. Okay, so let's finish this up. So first thing, putting it in standard form. So look at my polynomial. I have 3x plus 9x squared plus 5. So 9x squared, that's my highest exponent. It's a positive out front, so I'm going to put the positive 9x squared out front. Sweet. Now, a 3x and a 5, remember, that x has a 1 exponent, and the 5 technically kind of has an x to the 0 that we never have to write. So, obviously the next one would be let's get rid of that x to the 0. the 3x. And same thing, it's positive, so I'm going to put plus 3x. And then at last I got my plus 5. So look at my exponents here, 2 to 1 to none. Okay, so that's going to put that in standard form. Now, my highest exponent here is this 2. So I'm going to put a degree of 2. And then from our list above, if your degree is 2, that makes this a quadratic. Okay. Okay, that one, not too bad. Now, the second one here, there's kind of one maybe slight weird thing. So as I go through and look at this next polynomial, you have 4x, 6x squared, x to the 4th, 10x squared, 12. Okay, so like looking at all these, all right, obviously your highest one is this x to the 4th right here. So I'm going to start off with that x to the 4th. Now, notice how there is no x to the 3rd, because naturally that would be my next one, right? X cubed. But I don't have any cubes here. So then I'm just going to skip it and move down to the next one, all right? I don't need to fill in anything for x to the cube, no 0x cubed. But I'm going to look at the x squared. Now, here's the thing. There are 2x squareds here, right there and right there. I want to combine these if I'm putting it in standard form, okay? It's just like combining like terms from whichever math class you learned that, okay? A couple years ago, right? So minus 6x squared plus 10x squared, I'm going to combine that into a positive 4x squared. So right now I've taken care of the x, 4, negative 6x squared plus 10x squared. And look, that leaves me with a positive 4x and a negative 12. The 4x needs to come next, and then the minus 12 after that. There's my standard form. So the degree is 4. And to classify it by that degree, if you want to look at your list again, a degree of 4 is a quartic right there. So this was a quartic polynomial. Okay, so a little weird with that one with having the combining like terms in there. All right, so these last couple ones here, 3x cubed plus 5 minus x. The 3x cubed, that is already my largest exponent, so I'm going to leave that in front. But then look, I have to flip-flop these two around. Remember, you got to keep signs. Signs is the thing we got to watch for here. You got to keep that minus with x, that one right there, and then you got to keep this plus with 5. And that is going to be my standard form for this equation. So my highest degree here, my highest exponent is 3. And 3 is going to be, if you reference that list above, a cubic. All right, finish this up. This last one here, we just got to flip-flop them. Look, x squared and 2x to the 5th. So x to the 5th got to go first. Same thing, watch your signs. It's a positive 2x to the 5th. And a negative 4x squared, so keep those signs with them. This degree ends up being a 5, which, if we take a peek up here, that would be your quintic, if we're classifying by degree. Okay, so there's 4 examples of putting it into standard form. Identifying your degree, your highest exponent, and then classifying by that degree. Obviously, the last thing that we didn't do was you could classify these by number of terms. So if you just roll through that real quick, like that would be a trinomial. Here is a polynomial with 4 terms. There is another trinomial, 3 terms, and then there is a binomial with 2 terms. So there's different ways you can classify a polynomial, and then also looking at a couple different vocab words. Cool.